5. All right, so here we go. So we're going to do a review for quiz 3, which is all about parabolas. Okay, so today's date, 10/11/18. All right, so tomorrow's our quiz. Number 1, I am sure hoping that no one misses number 1. I really am. I mean, this is the most basic x squared. This is basically our parent function. Everybody should get this right, okay? How do we graph it? Well, it's easy. I'm just going to do the t-table in my head. 0 squared is 0, right? 1 squared is 1. 2 squared is 1, 2, 3, 4. And 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? It's our parent function for x squared. We also know that it is symmetrical because the line of symmetry goes right down the middle. And so my parabola should look something like this. It's supposed to be curvy. Make it curvy. Don't make it pointy because it is a parabola. So then, easy. The vertex is at 0, 0, right? It's right there. Vertex is at 0, 0. It's a minimum value. The line of symmetry, the LOS, is simply x equals 0. Thumbs up? Everybody can do that. That might even be question number 1. All right? Might just be problem number 1. How hard is that going to be, okay? All right, let's look at number 2. Number 2, okay, now again, I think I can graph this. It's just going to be our first graph, just pulled down 9, right? So we're going to take this parabola, just drag it down 9 units. So I'm going to go ahead and make an x, y. But I got to go all the way down to -9, so I'm going to make it super long like that. I already know that it starts at -9, so I'm going to put a point at -1, -2, 3, 4, 5, 6, 7, 8, 9, right? And again, from the vertex, I just do the t-table in my head. 1 squared, 2 squared is 4, 3 squared is 9, and then the rest are too big, right? So if I start at the vertex, I go over 1, 1 squared is 1. If I go back to the vertex, go over 1, 2, 2 squared is 4, 1, 2, 3, 4. If I go back to the vertex, I go over 1, 2, 3, and 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9. I know there is a line of symmetry that goes right through the middle, okay, at x equals 0, right? And since we have a line of symmetry, it's symmetrical, so I can fold or reflect the points over the y-axis. And here's my parabola. So again, I'm going to draw it nice and curvy, not pointy, because it's supposed to be curvy, okay? So, pretty easy so far, right? Our LOS, or our line of symmetry, is simply down the middle, which is x equals 0, right? Our vertex is down here at the very bottom at 0, -9. Our vertex is 0, -9. Am I going slowly enough?
Yeah.
Okay, thumbs up. Okay, good. Let's take a look at number 3. Okay, so number 3 is quite a bit like 1 and 2, except for we're going to have a little bit of a modification. 2 things. It's going to be upside down because of the negative, and it's going to be half as tall. So, all right, I'm going to start up at 10. So when I do my x and y axis, I have to start up at 10. So I'm going to try and make my graph look like this. So I got to start all the way at 10. Here's my x and my y axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Right there, 10. So I'm going to start up at 10, and I'm going to go down. I'm going to go down because of the negative, right? But I'm going to go half as tall. So Zoe pointed that out. We're not going to go 1, 1. We're going to go 1, 1/2. We're not going to go 2, 4. We're going to go 2, 2 because half as tall. We're not going to go 3, 9. We're going to go 3, 4.5 because we're going to go half as tall. Except for we're not going tall. We're going down because it's negative. Got it? So from my vertex, if I go over 1, I'm going to go down a half, okay? If I go over 2, I'd normally go down 4, but I'm going to go half of 4, so I'm going to go 1, 2. Go back to my vertex, go over 1, 2, 3. I'd normally go down 9, but I'm going to go half of that, so I'm going to go 4.5. 1, 2, 3, 4.5. Okay, and of course it keeps going down. We could actually do the other one, but we don't need to. We know there's a line of symmetry, which goes right down the middle at x equals 0. So if I have a line of symmetry, I can reflect the points over my line of symmetry here, here, here. And I can just draw my graph in nice and curvy, not pointy. There's number 3. So the vertex for 3, line LOS, line of symmetry, is x equals 0. And the vertex is at the point 0, 10. Not too bad, is it? This should, I'm hoping this is going to be the best performance on a quiz. It's going to be awesome. So let's take a look at number 4. Now number 4 is in a different form. In fact, if I look at my notes, number 4 is in this form, right? The parentheses. Number 4 is in this form here. So what I know about number 4, first of all, is the vertex. I know my vertex is at -5, -3, because it's got to be the opposite of the inside, right? It has to be the opposite inside because that's the value that would zero it out, okay? So that means my LOS, my line of symmetry, has to be x equals -5, right? So it's got to be the opposite of the inside and then the -3. So if I'm going to graph this, okay, let me get my xy axis here. So at -5, -3, 1, 2, 3, 4, 5, and 1, 2, 3. Now there's an invisible 1 in front of this. There's an invisible 1. Am I going too fast? There's an invisible 1, so I'm still going to do my regular 1, 1, 2, 4, 3, 9 because it's still a standard parabola. There's no 1/2 in front. There's no negative in front. So from here I'm just going to do my 1, 1, 2, 1, 2, 3, 4, 3 from the vertex. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. I know there's a line of symmetry which goes right through the vertex, right, at x equals -5. And because I have a line of symmetry, I can fold or reflect my points over the line of symmetry. I get the points. I can draw my parabola in nice and smooth. Okay. Thanks, Sydney. Thumbs up. It's pretty easy, isn't it? Pretty easy, okay? All right, number 5 is the one that's going to take some work, but we can do that. I don't mind. We can do a little bit of work on 5. So number 5 is in the what we call standard form. Okay, it's in standard form. So we've got to use our -b over 2a. Okay, and then once we get that, we have to plug that in to get our corresponding y. Okay, so let's check it out. I know that my a is 1, my b is 4, my c is -7. So a is 1, b is 4, and c is -7. Okay, how am I doing? All right, now I need my formula. X equals -b over 2a, right? So let's see, I've got a 4, which is going to go in for b. So I've got -4 over 2, because that's in the formula, times a, and a is 1. Okay. So if I simplify that, I get a -4 over 2 or -2. So my LOS, line of symmetry, is x equals -2. Okay. Now my vertex, I have half of my vertex. I already do. Half of my vertex is the -2 because the line of symmetry goes through the vertex, right? Goes through the vertex, so I've got the x value. So I know my vertex is at -2 something. We just need to find the something. So I'm going to take my -2 and plug it in for x. Right? So I'm going to rewrite this y equals x squared plus 4x minus 7. And I rewrote it only so that I could show you that I'm going to put in the -2 in its place. Okay? So I'm going to plug -2 here and here. Okay? So I'll go y equals -2 squared plus 4 times -2 minus 7. And again, there's nothing wrong with using a calculator. Sometimes you make mistakes. This is going to be a positive 4. Okay, -8 minus 7. So if you just let your calculator do the work. It makes it really easy for you. Parentheses, negative 2 squared plus 4 times negative 2. Subtract 7, and I get an answer of negative 11. So y equals negative 11. So there's my vertex, okay? Now, if I go to graph this, let's see what I've got. Okay, so if I go to graph this, I'm missing a point. But that's okay. I can probably take it from there and get another point. So let's see. Let me go ahead and get this paper so I can see it. So I know my LOS, my line of symmetry, was x equals negative 2, and my vertex was at negative 2, negative 11, okay? So if I take my graph paper, I'm going to go ahead and try and graph that. And I'm going to go to negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, there's my vertex. And I know also that I have another point. There's one other point, and that's at negative 7. Because I have a y-intercept of negative 7. Okay, so I'm going to go to 1, 2, 3, 4, 5, 6, 7. I need 3 points, but the third point's going to be easy to get because I have a line of symmetry, right? So I know if I were to fold or reflect this point over the line of symmetry, there's my third point. And you don't have to be perfect today or tomorrow, but it has to be pretty good. If you have those 3 points, just sketch it in. So tomorrow I will be looking to see if you have the 3 points and the parabola in the right place, okay? Now, almost done, right? This is getting pretty easy. So, 6. Here's a real problem, okay? A baseball is thrown into the air and follows the equation. H for height equals negative 16 t squared plus 100, okay? At what time is the ball at its height? Now, before I go any further, I need to explain something in physics, okay? This is height and time. This is not its path, okay? You ready? Caleb, this is perfect for you because you need something to do, okay? So if I throw the pin to you, okay, that's not what, I want to throw it back. Throw it back. That's not what's going on. Watch, this is going on. Weird, isn't it? This is what's going on. Because as it's going up, time is moving, right? So your x-axis is time. So watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your axis is time, and your y-axis is height. It's not, ready, Caleb? It is not this path because we're not measuring how far it goes. We're measuring how high it goes over time. So when I take a look at a graph of this one, this is time in terms of seconds, right? And this is height. Now, a lot of kids get this goofed up because they don't realize the difference, but there is definitely a difference. We're not asking where it goes. We're saying how high is it over time. Okay, so it's the same thing, okay? So first of all, at what time is ball at its highest height? Well, that's got to be its vertex. You guys agree with that? It's got to be its vertex, okay? So the graph is going to look something like this. Something. It's going to look something like this, okay? So we need to find its vertex. So the vertex, it's in our other form. I'm going to use my negative b over 2a to get my x. So I'll take my negative 100 over 2 times negative 16, which is a 100 over 32, and I'm just going to use my calculator to figure it out. Okay, so 100 divided by 32, oops, hold on, 100 divided by 32, and I get about 3.125. So t equals 3.125. Okay, so that makes sense. That's time. So the ball's thrown in the air, and at 3 seconds, count it, 1001, 1002, 1003. Did I make a mistake?
Wouldn't it be negative 100 when you changed it to positive 100?
I did, because the negative with this negative is positive. Thank you, but if I do make a mistake, please catch me, Ava. But you see why it's positive? It's the negative and the negative. It's a negative 100 over negative 32, right? And we can't have negative time anyway, can we? No. So at about 3 seconds, it's at its highest. How high is that? Well, we got to plug that in. Okay, so the time is 3.125 seconds. The height, we have to plug that in. So we'll go h equals negative 16 times 3.125 squared plus 100 times 3.125. And again, I'm going to use my calculator. I'm going to go ahead and just plug them in. So we'll go negative 16 times 3.125 squared plus 100 times 3.125. And my height is about 156.25 feet high. Okay, can you do that tomorrow?
Wait, do you want us to just, okay, why did
Zoe?
I